Hello and welcome to ATG 4950. When we mention the word product, you may think tangible goods such as cars, microwaves, and etc. While actually products include goods and services, which means that your insurance policy is considered as a product and your mortgage is considered as a product. In this session, we will go over the product life cycle and some of the issues to be considered during product development, concentrating mostly on tangible goods. This figure shows the product life cycle, and it starts with the introduction, then the growth, the maturity, then the decline. So it has four phases. Whether it's goods or services, it has four phases, and those are the phases that goes through. This is an example where we have the DVD started, then the growth of the DVD, then at the end how it will decline. For the DVD here, that was back in the 1999 or the 2000, the beginning of the 2000. The DVD was a startup or in the growth. The CD-ROM was almost at the end of the growth, while the 3.5 floppy disk was in decline and minimizing or decreasing in the number of 3.5 floppies in the market. In the introduction, most of the research and development and the looking at the market and the market need. Then in the growth, we have the change in quality and in price. At this point, you get the strength. Now, in the third phase, you have a mature product that's selling, but at the end of that stage, the need for the product might change. If the need for the product change, it will start declining, where it goes to critical cost control. And we need to control the loss from this one. Most of the time, you have to have another product that's prepared to pick up in this stage and take over the decline of the previous product. So the design and development team role is concentrated mainly in the first phase. You will see in the other phases there are participation from engineering or from the development or design team, but not as much as in the first phase. So the first phase, or the introduction, we have the product design and development, which is critical. Then we have frequent product process design and changes. Then we have short production runs, high production costs, limited models, and attention to the quality. Then in the growth, we forecast what's going to happen with the market. Then product and process reliability. Then we have the competitive product improvements and options, especially if we have a rising competitor in the market. Then we increase the capacity to make mass production and shift towards product focus and enhance the distribution for that product. At the maturity level, we have standardization, less rapid product changes, more minor changes, optimum capacity, increasing instability, and long production runs, and product improvement and cost cutting. In the decline, little product differentiation, cost minimization, overcapacity in the industry, prune line to eliminate items not returning good margin, and then reduce capacity. If we look at the different products, we might see that some of these products may have long life cycle or long life, and others has short life cycle. For example, the newspaper can be considered as a short life cycle, while the shuttle is a long life cycle product. So in the introduction stage, the product is tuned for the market. This tuning will be done through research to identify the product goal and analyze the market acceptance to such new product. Also, a study will be conducted to identify the targeted audience. The research results will be reported to the team of developers to start product development based on market and customer specifications. For you, you can do a survey. We don't have another team for reporting or for research. You are the same team, so one of the members can do a survey and can collect the research results and report it to the other team members, where you can improve on the specifications of the product. Through prototyping and testing the product, you will modify and enhance the final release. Included in the research will be findings for the best reliable supplier for the material needed in the production stage. You don't want a supplier that will cut you in the middle of the production, not having the sufficient amount for you to continue producing your product. In the growth stage, the product design will begin to stabilize and forecast for the capacity and demand will be necessary. In this stage, the enterprise has to decide on adding or enhancing their capacity to satisfy market needs. In the maturity phase, the product should be able to compete in the market with the ability to produce high volume or use innovation or innovative way of production if needed. With the experience gained about the product, managers will be able to improve and control the cost and reduce some of the options or maybe activities or processes. Those are the activities. I'm reducing the activities or processes that does not add value to the customer and will not be willing to pay for it. The customer will not be willing to pay for it. In the decline phase, let's go back. In the decline phase, the product demand will start declining unless the product makes special contribution to the organization. It will not actually stay in the market, or it will not be a product that will bring money to the organization. So it should contribute to the organization profit. Otherwise, you can terminate, or you will have a plan to terminate or exchange that product with another product that will pick up. For example, Intel CPUs, as soon as a processor declines, they offer a new technology to replace the old one, either by the speed or now by doing the dual processing or quadratic processing. So the ability to increase the speed or change the processing method to make it more efficient, that will pick up in the market, and you have a new product that is taking over the life cycle and so on. This graph shows that leading companies generate a substantial portion of their sales from new products less than 5 years old. But not all new products will succeed. Actually, it will take almost 250 ideas to produce one product. To identify new product opportunities, we need to understand the customer need and customer wants. Most of successful new product ideas comes from users or being developed by lead users. Also, we need to look at the economic change, which will allow people to afford buying new products and new technology. For example, the current economical situation is not a good time to try buying new product and new technology, although it's picking up now, but still it's not fully recovering or fully recovered to buy the highest end technologies in the market. There are also some psychological changes that might also affect the product demand. For example, family size decreased. So they are moving from a bigger car to a smaller car. Technological changes such as handheld devices and cell phones, where everybody now have a smartphone. Political changes such as new trade agreement or government contact that eliminate or minimize taxes. Other opportunities might come from market practice, professional standards, suppliers, and distributors. So actually brainstorming is useful tool to collect the needed information or to get a new idea for a new product in the market. This figure shows the product development process starting from the idea and ending up with the evaluation. It highlights where the scope of the product development team and the scope for the design and engineering teams. So it starts with an idea, the ability to do or to implement that idea, the customer requirements, start collecting here the customer requirements, functional specifications, product specifications, design review, test market, introduce or introduction, and then evaluation. When we are developing a new product, we use quality function deployment, QFD, to map and translate customer wants into design specifications. This process is used early in the design process to capture the characteristics of the product that will satisfy customer wants. One of the tools that is used in quality function deployment is the house of quality. To develop a house of quality, we need to perform the following steps. First, to identify customer wants. Then to identify how the good or service will satisfy customer wants. Then to relate customer wants to product house, identify relationships between the firm's house, and develop important or importance rating, then evaluate competing products. As you can see in this graph, the house of quality is a graphical technique for defining the relationship between customer wants and product design specifications. We have an example here where let's assume that your team has been assigned to design a new camera for Great Cameras Incorporated. So the first action is to construct a house of quality. Let's capture what customer wants. They need a lightweight, camera, easy to use, reliable, easy to hold steady, and no double exposure. When we asked our customer about how important that for them, they said for the lightweight it's 3, for the easy to use it's 4, for reliability 5, easy to hold steady 2, and no double exposure 1. Now let's find how can we satisfy customer wants. For the reliability, we have low electricity requirements. For the weight, we have aluminum components. For the easy to use, we have auto focus, auto exposure, auto film advanced, and we have an ergonomic design that will help in holding it and in the other functionalities or the other needs of the customer. Now let's map customer wants with how to satisfy options, which will be represented by high, medium, or low relationship as indicated in the figure in this slide. Let's go back. So for a low relationship, we have the dot or period. Then we have a circle. Then we have a circle with a dot in the middle. So for the high relationship, the circle with a dot. The medium relationship, just a circle. Low relationship, just the dot. We can also identify the relationships between the how to satisfy options with each other. So what's the relation between low electricity requirements with aluminum components? Oh, we don't have a relation, then we don't put anything. But with the electricity, with the autofocus, we have a very strong relation. With the auto exposure, we have a very strong relation with the autofocus and with the low electricity requirements, and so on. So we are identifying the relationship between the wants or what customer wants between each other. Then we can calculate our weighted rating, assuming that low relation is 1, medium is 3, and high is 5. Then we can say that for the first column, 3 times 1, that's the importance. So it's 3 times 1 plus 4 times 1 plus 5 times 3. So 5 times 3 is 15, plus 4 is 19, plus 3 is 22, and that's column 1. If we try the fifth column, we can see that this is 3, this is 3, and this is 5. So 4 times 3 is 12, plus 15 is 27, plus 5 is 32. Now let's see if we have other company that produces the same product and how well their product meet customer wants, where P for poor, F for fair, and G for good. So we have two companies, Company A and Company B. Company A has good for lightweight, good for easy to use, fair for reliable, good for easy to hold, steady, and P or poor for no double exposure. While the second company has poor with everything except reliability, it's good. Then we need to include the technical attributes of the product and the technical evaluation for your company versus other companies. If we put all that together, then this is the overall picture of the house of quality, and by looking at that, we can identify the product specifications and technical aspects. Based on the developed house of quality, we can identify how are we going to deploy resources through the company in response to customer requirements, starting from the design characteristics to specific components to production process to the quality plan. So the main focus of the QFD is to capture the customer need. If customer needs can be identified from the beginning, wasteful effort and time spent redesigning the product could be eliminated. We need to determine what satisfies and dissatisfies our customers. Through history, it shows that organizations always used a distinct department for product development with certain duties and responsibilities. While in current organizations, they are concentrating more on team approach, where the development team has cross-functional representation or representative from all discipline or functions. The research of a product or product development should include manufacturability. That means, could it be manufactured? What are the activities that is needed to improve that design and specifications during that research? The benefits from that will be reducing complexity of products, additional standardization of products, improve functional aspects of product, improve job design and job safety, improve maintainability of the product, robust design, and not to forget cost reduction. For example, through value engineering, we can look at the design and see how we can produce the same product with lower cost. In this example, the bracket shown here, which was made from different material and was welded, the screws and bullets that were used in the first design are eliminated. So we eliminated this. We move to this one, and with this one, no screws or bullets were used, and the price decreased from $3.50 to 80 cents a piece. When developing a product, we need to look at the design needed and see if it should be robust and based on some standards. If it's possible, some computer-aided tools will be nice to have and to use, such as CAD or CAM. Maybe also it's possible to use other technologies such as virtual reality technology, or analyzing the value of the product and pushing towards an environmentally friendly design. So when we say robust design, I mean the product is designed so that small variation in production or assembly do not adversely affect the product. Typically results in lower cost and higher quality. Product design in early segments components and adding or that will add actually flexibility to both production and marketing and improve the ability to satisfy customer requirements. Using computers to design products and prepare engineering documentation shorter development it make the development cycle shorter, and it will improve accuracy and it will lower cost. Information and designs can be actually deployed worldwide, where now you can share these designs through the internet or through any kind of communication tool with people across the world, sharing with them your design and actually improving on the design. Utilizing specialized computers and programs to control manufacturing equipment, often driven by CAD system. So the benefits of CAD and CAM is to increase product quality, shorter design time, reduce production cost, make the database available for analysis, and it's a new range of capabilities. For the virtual reality technology, it's a computer technology used to develop an interactive 3D model of a product from the basic CAD data. This kind of technology, it allows people to see the finished design before a physical model is built. It's very effective in large-scale designs, such as plant layout. It's not very effective in small products because the cost of the virtual reality will be way more than a small product design. So we are looking at large-scale designs. For the value analysis, it focuses on design improvement during production. And this kind of analysis seeks improvements leading either to a better product or a product which can be produced more economically. During the production and design and looking at how we can develop the product, we need to look at some of the ethics and environmentally friendly designs or approaches or capabilities of development. For example, we view product design from a systems perspective, and we consider the entire life cycle of the product. Then we develop a safe and more environmentally sound products. We will try to minimize the waste of raw material and energy. We will try to reduce environmental liabilities, and we try to increase cost effectiveness of complying with environmental regulations and be recognized as a good corporate citizen. It will be good to make your product recyclable through using recycled material, less harmful ingredients, lighter components, and less energy consumption and less material. Like we said, we need to look at the standards and the regulations. So we need to look at our designs and see if actually the Federal Drug Administration has anything to do with that, and look at their standards, what kind of rules they have, and follow their standards. Also, we need to look at the Consumer Products Safety Commission, the National Highway Safety Administration, Children Product Safety Act. Whatever relates to our product, we should look at those organizations, those standards, and follow these standards. For manufacturing assembly standards, we have the Occupational Safety and Health Administration, OSHA. We have the Environmental Protection Agency. We have the Professional Ergonomics Standards. we have state and local laws that actually dealing with employment standards and with discrimination and with even product licensing and production and manufacturing environments. Also for standards for the disassembly or disposal. For example, when you go to Walmart and you want to replace your battery, they will charge you a certain amount of money to return the battery back, or the dead battery back to them, so they can recycle it the proper way. So there are certain standards to dispose from some of the items that you use on a daily basis. The most important things is like the batteries, or the oil that you use, the tires. All these can be recycled and disposed properly. That's why they charge for as its a disposal fee to get rid of these items. For product documents, we have two types of documents. We have internal documents that can be submitted to the administration and to the teams where they can view it, such as engineering drawing, bill of material, and brochure, which will be submitted for the marketing department. For example, for the engineering drawing, it shows dimension, tolerance, and material, and it shows codes for group technology. For the bill of material, it lists component quantities and where used, and it shows product structure. And for the brochure, it's a marketing material for the product. This is an engineering drawing example, and we can see all these dimensions and the tolerance and other values or other important numbers. Bill of materials, and this is an example of a panel weldment. We can see the quantities, the material used, and the number for that product. Then we have another example for bill of material, like a barbecue or cheeseburger, and you can see the components of a cheeseburger, how it's being assembled or made. For the external document, external could be for the customer or the end user, such as user manual, which shows product specifications, different functions and dimensions, the tolerance and materials, and also it shows step by step on how to use the product. Then we have the assembly drawing. And assembly drawing, this is an example of assembly drawing that will show how this part or this product being assembled or can be assembled. The last thing that we would like to address is the service. And again, the service is a kind of product, but it's totally different than the tangible product, and it has its own methods and strategies on how to get the information, collect the information needed, and identify the need for a new service, then offer it to the public. So service typically includes direct interaction with the customer. There are increased opportunities for customization and reduced productivity, and the cost and quality are still determined at the design stage. We have delay in customization, modularization, and we have reduced customer interaction, often through automation. And we are talking about different services that can be done through automated with less customer interaction, such as ATM machines. That will be all for this session. If you have any questions, you can send it to me through Florida Online. Thank you and have a great day.